Functional group in organic molecules is an atom or group of atoms which gives functionality to the molecule. Example: alkene, alkyne, alcohol, ether, nitro, halo, aldehyde, ketone, carboxylic acid, ester, acid halide, anhydride, amine, amide are few functional groups. We will be identifying all these functional groups in this video. An organic compound can be called as alkene when we have minimum one C double bond C present in the system. With the molecules where more number of carbon atoms are present, it is enough if we have one double bond to be called as alkene. Imagine in a molecule we are having C double bond O and no C double bond C is present, C double bond N is present, or C double bond S is present, then it cannot be called as alkene because double bond is not between two carbon atoms. In the same manner, to call an organic compound as alkyne, we have to have a minimum of one triple bond. We may be having many single bonds in the system, but presence of one triple bond makes it a alkyne. If we have C triple bond N present in the system without C triple bond C, then it cannot be called as alkyne. Alcohol functional group means presence of OH in the system where oxygen is connected to carbon atom. This is also written as COH. Keep in mind, OH has to be connected to carbon. In case if it is connected to hydrogen, then it becomes water and not alcohol. Ether is a functional group where we have oxygen atom connected to two carbon atoms. Observe the difference between alcohol and ether. In alcohol, we are having oxygen connected to carbon on one side and hydrogen on another side. In ether, we have oxygen connected to carbon on both sides. Nitro functional group indicates the presence of NO2 in the organic molecule, where nitrogen of NO2 is connected to carbon atom. If we expand and write the NO2 part, then nitro looks like this. Nitrogen is having a double bond with one oxygen and single bond with another oxygen. This nitrogen carries positive charge and oxygen carries negative charge, so nitro as a whole is neutral. Keep in mind, nitrogen has to be connected to carbon to be called as nitro functional group in organic molecules. If this nitrogen is connected to hydrogen, then it becomes the acid HNO2. Recall, presence of double bond between nitrogen and oxygen doesn't make it a alkene. Coming to the halo, this word represents the presence of halogen, which is generally indicated with the symbol X. This may be fluoro, chloro, bromo, or iodo. To be called as halo functional group in the organic molecule, we have to have this halogen connected to carbon atom. If this halogen is connected to hydrogen, then it becomes the acid HX. So, connection of X to C or connection of nitro to carbon atom makes these as nitro or halo functional groups in organic compounds. Both aldehyde and ketone functional group consists of C double bond O present in it. We know that carbon is having valency 4. So the carbon in both the case must be having two more bonds. Aldehyde functional group is compulsorily connected to hydrogen on one side. On the other side, there is no restriction, meaning it can be connected to hydrogen or it can be connected to carbon atom. When it comes to ketone, on both the sides, it must be connected to carbon to be called as ketone. I repeat, C double bond OH is aldehyde. C double bond OC is ketone. Aldehyde sometimes is written as CHO in short, whereas ketone will be written in this manner itself most of the time. Common part in carboxylic acid and ester functional group is the presence of C double bond O group. We know that oxygen valency is 2. So this oxygen must be having one more bond on it. In case of carboxylic acid, this oxygen is connected to hydrogen, and in case of ester, this oxygen is connected to carbon. On the other side, this C double bond O carbon can be connected to hydrogen or carbon in both carboxylic acid and ester. This part of carboxylic acid, we can even write it as C double bond OH or COOH or CO2H. Most often, ester is represented like this only. Just now we learned that carboxylic acid functional group has C double bond OH in it. On the other side, this carbon can be connected to either hydrogen or carbon. Let us write one more molecule of carboxylic acid, C double bond OH. On the other side, hydrogen or carbon. If we remove a molecule of water from these two carboxylic acid, what do we get? Let us write that. We are left with carbon or hydrogen connected to C double bond O and a bond from the first carboxylic acid. O, C double bond O, hydrogen or carbon from the second carboxylic acid. This itself is called as anhydride. Removing a molecule of water from 2-carboxylic acid gives us anhydride. Sometimes we write anhydride as C double bond O, C double bond O and a bond. On this side, it can be connected to hydrogen or carbon. Even on the other side, it can be connected to either hydrogen or carbon. Both acid halide and amide functional group consists of C double bond O part in its functional group. We know that carbon valency is 4, so this carbon must be having one more bond on it. Word halide represents halogen atom, which is normally indicated with the letter X. In case of acid halide, this carbon is connected to halogen atom on one side, and on the other side it can be either connected to hydrogen or carbon. So to call something as acid halide, presence of C double bond O X is must. Coming to the amide, to call something as amide, this carbon must be connected to a nitrogen atom. On the other side, it can be either connected to hydrogen or carbon. We also know that the valency of nitrogen is 3. Since we have written only one bond over here, there must be 2 more bonds on nitrogen. So, to call something as amide, presence of C double bond O nitrogen is must. If this nitrogen is connected to 2 more hydrogen atoms, then we call that amide as 1-degree amide or primary amide. If that nitrogen is connected to one carbon and another hydrogen, then we call that amide as 2nd-degree amide or secondary amide. If the nitrogen is connected to 2 carbon atoms, then we call that amide as 3-degree amide or tertiary amide. Amine functional group in organic chemistry consists of nitrogen connected to a minimum of 1 carbon atom. We know that nitrogen valency is 3, so there will be 2 more bonds on nitrogen. Through these 2 bonds, nitrogen can be either connected to hydrogen or can be connected to carbon atom. If nitrogen is connected to hydrogen through 3 bonds, then it will not be called as amine but will be called as ammonia. Depending upon what is present on these 2 bonds, we are having 3 types of amines. If we have 2 hydrogens and 1 carbon connected to nitrogen, then it is a primary amine or 1-degree amine. If nitrogen is connected to 2 carbon and 1 hydrogen, it is a secondary amine. If nitrogen is connected to 3 carbons, then it is a tertiary amine or 3-degree amine. Keep in mind, to call something as amine, nitrogen should be connected to a minimum of 1 carbon atom. Coming to nitrile, this is also called as cyanide functional group. Presence of C triple bond N is must to be called as cyanide functional group. Added to that, this carbon must be connected to another carbon. If this carbon is connected to hydrogen, then it becomes hydrogen cyanide acid. This C triple bond N part is normally written in short as CN. Let us try to identify the functional group from one side. Here we are having C triple bond N connected to the carbon atom. So this is nitrile or cyanide. This is nitrile. Then over here we are just having carbon atom. Coming to down, we are having C connected to OH. This indicates alcohol. Here we are having NH2 connected to CH. That means nitrogen is connected to 1 carbon and 2 hydrogen. So this is a primary amine. Then we are having carbon connected to C double bond O, OH. So this is carboxylic acid. Going up, we are having CH connected to chlorine, that is halogen. This is chloro or halo functional group. Then we are having C connected to O, that is connected to C. This indicates ether. Here we are having a double bond. So this is alkene. Then here we are having NO2 connected to carbon. This is nitro. Then we have C connected to C double bond O, that is further connected to C. This is a ketone. Then we have C connected to C double bond O, that is connected to H. This indicates aldehyde. Let us find out from this side. C double bond ON indicates it is an amide. Since this nitrogen is connected to 2 carbon and 1 hydrogen, this is a secondary amide. This is a secondary amide. Coming down, C double bond OC, this is an ester. Then C double bond OCl, this is acid halide. Since the halogen is chlorine, we can call this as acid chloride. Going to the right, we have a triple bond between 2 carbon atoms. So this is an alkyne. Going up, C double bond O, C double bond O. This is anhydride.